Okay, here we go. Video 1.3, we're going to learn about what's called average velocity. We're also going to talk about average speed. Before I start, I should clarify something. I made a mistake in the last video. We're going to learn about today what are called average velocity. We're going to learn today about what are called average velocity and average speed. Notice when we're talking about an average quantity, we put a line over the variable. Now, in the last video, we talked about instantaneous speed and instantaneous velocity. And notice, because there's no line, that indicates instantaneous. And there was one point in the last video where I mistakenly put a line over these guys, and I shouldn't have. And I spoke about that in class, but just want to remind you that a line over the variable means average, no line means instantaneous. Okay, so here we go. We're going to start by learning two definitions. The first one is for average speed. To calculate average speed, we take the distance that an object travels and divide it by the time that that took. That gives you the average speed. Okay. Calculating average velocity is similar, except instead of using the distance, we use the displacement and divide that by the time. Okay, so both of them are going to measure kind of how far we go, distance or displacement, per unit time. Okay, mathematically they're going to give us slightly different answers though, which is illustrated by this example here. All right, so suppose Roy drove his car 300 miles to get from Detroit to Chicago in 5 hours. Find his average speed. So the idea is the 300 miles is how far he actually had to drive. Okay, so that's our distance, 300 miles. Okay, and then it tells you that the time is 5 hours. So we want to find our average speed. Notice how I solved this, you guys. I wrote down the three things I knew, or the two things I knew, and I wrote down what I was looking for. All right, now that I've done that, I'm going to write down the equation that I'm going to use to solve it, and then I'm going to plug in the numbers. My distance is 300 miles. Time is 5 hours. Grab your calculator or your brain, divide it out, and you get 60 miles per hour. So there we go. There's his average speed. All right, he averaged 60 miles per hour. It's worth noting that that's the average speed. It's not his instantaneous speed. Okay, as he's driving from Detroit to Chicago, his speed could change. So there might be moments when he's going 80 miles an hour, you know, when he's on the freeway and he's cruising, and there might be moments where he stops to eat a taco or whatever, okay? So 60 miles per hour is his average speed. During his trip, he averaged 60 miles each hour, okay? Now, when he drives from Detroit to Chicago, even though he might have traveled 300 miles, his displacement is going to be significantly less. Check it out. Let's look at this map here. All right. So down here in blue, I don't know if you guys can see this, here's the path that he followed. He took, whatever, 94 all the way down. He took a turn, and so that blue line there is the distance. All right. His displacement, though, remember, displacement is supposed to be a straight line. So his displacement would be this purple line that I'm about to draw from Detroit to Chicago, right? Oops. Okay, so that purple line there represents his displacement. And you can see it's shorter, right? Because it's the shortest distance between 2 points. All right, it's not perfectly, but for simplicity, let's assume that he's going, that's straight west. It's pretty close. He went a little bit south, but we're going to just, to keep it simple, assume that he went west. So the idea is his distance was 300 miles. His displacement, the purple line that I just drew there, is only 200 miles. And added to that, because, like I said, it's going to the left, to the west, we need to remember to make it negative. Okay? So what the second part of example 3 is showing us is that the average velocity is different. Okay? So suppose Roy drove his car from Detroit to Chicago in 5 hours. So time is 5 hours. Chicago is 200 miles west of Detroit. That's telling me that his displacement from starting point to ending point is 200 miles. And notice the negative sign is there because he went west. Okay, and we're trying to find average velocity. So once again, I started by writing down what I knew. What am I looking for? Now I'm going to write down my equation and divide it out. He went 200 miles west in 5 hours, which is negative 40 miles per hour. So there's his average velocity. Okay, notice the average velocity is less, right? Because when you look at average velocity, you're looking at how far it is from start to finish, how far he moves towards his finish point per unit time. And the idea is, in part of his trip, he drove south, in part of his trip, he drove north, and that's sort of just wasted effort, right? Because overall, he's just going west. Okay? So, let's do another example here. So suppose Roy rides his bike 18 miles south, then turns around and goes 6 miles north. The entire trip takes him 3 hours. So A says what's his average speed, and B says what's his average velocity. So there's a lot of information here. There's two things that have to do with distance, right? There's 18 miles and 6 miles. I can pretty safely write down the time. I can say, oh, cool, the time is 3 hours. And same thing down here, the time is 3 hours. But in order to find my average speed, I need to know the distance he drove. And down here, for part B, to find my average velocity, I would need to know the displacement, right? So basically, this is going to be a two-step problem. Find your average speed, and then find your, find your distance, and then find your average speed. All right, so let's draw it. All right, Roy rides his bike. So let's pick a starting point. Start. Okay, and he goes 18 miles south. Got to make the sound effect or it won't work. He went 18 miles that way. And then he turns around and he goes 6 miles north. So make that line shorter because he didn't go as far, right? So hopefully you remember from the last video, to find the distance, we just need to figure out the total length of the path he follows, the total length of the red here. Okay, so the distance here is just going to be 18 miles plus another 6 miles. Gets him a total of 24 miles. So now, to find my average speed, I'm going to plug in my numbers. The distance he went was 24 miles. The time it took him was 3 hours. Divide it out, and you get 8 miles per hour. Okay. Now, to find the average velocity, it's a little bit different, right? Because for average velocity, instead of caring about the distance, which I've drawn here in red, we want to find the displacement, which I'm going to now draw in blue. Remember, your displacement goes from your starting point to your finish point. So my displacement is the length of that line. And again, some of you are doing this conceptually, where you're just subtracting the 6 and the 18 and saying, oh, that's got to be 12 miles. If you do it that way, don't forget to put in your negative sign because he ended up south of his starting point. All right. The other way that'll always work is to do it this way, to say, well, he went 18 miles south. Notice I made it negative because he went south. And then he went 6 miles north, which means that his displacement is going to be negative 18 plus 6, which gives you negative 12 miles. I'm totally out of room here. Poor board management, Mr. Hacker. So now we can find our average velocity. It's displacement over time. We went negative 12 miles in 3 hours. And so you get negative 4 miles per hour for an average velocity. So there's our average velocity. And up here we have our average speed. Okay. Again, your average velocity is less because your displacement is less, right? Because it's a straight line. Okay. All right, so let's talk about units. Whether you're talking about displacement or distance, for that matter, units that you would use for displacement. So far, we've used miles. You could use any measure of length, right? So you could use inches or feet or yards if you're a football player, or kilometers if you're in Canada. What we are ultimately going to end up using as we get farther into the class is meters. Okay, so as you're reading your problem, the problem is going to give you information. You have to identify what it is. You have to identify if it's distance or time or velocity or whatever. So if you see miles, inches, feet, yards, kilometers, we're going to label that as displacement. Okay, now time. Time, you guys know this, time can be measured in seconds, minutes, hours, days. Ultimately, we're going to end up using seconds. Okay, now velocity, because velocity is calculated by dividing a displacement by a time, it's always going to be, I should have done it this way, one of the red ones, right? One of these guys will be on the top, so you might have miles per one of these guys, hours, right? Okay, so what I have just done a rotten job explaining is the fact that your velocity is always going to have a unit of displacement per unit of time. Okay, so it could be, for example, miles per second, or miles per minute, or miles per hour, or inches per second, or inches per minute, or inches per hour, or whatever, but you always have that word per. Okay? So, ultimately, a lot of our problems are going to look like this. It's going to be fairly straightforward, where I give you information like this. It says Roy jogs at 3 meters a second for 12 seconds. How far does he go? Now, so here's the deal. If the problem doesn't say anything about the object turning or changing direction or anything, then I want you to automatically default to using this equation and those 3 variables. All right, because remember, if your object doesn't turn, then your distance and your displacement are the same, which means your average speed and your average velocity will also be the same. So if the object doesn't turn, you should write this down. If the object doesn't turn, I want you to use this equation and those 3 variables. Okay, so moving on then, it says Roy jogs at 3 meters a second. So write down what's given. 3 meters per second. Because of the word per, that's our velocity. Okay, he does that for 12 seconds. Because it's seconds, that's our time. And we're trying to figure out how far he goes, right? So we're going to have to do a little bit of algebra on this equation up here. Okay, so average velocity is displacement over time. And I want to solve for displacement. So to get displacement by itself, I'm going to multiply both sides of the equation by t. These guys cancel, and you get average velocity times time equals displacement. Okay? So these 2 equations here are the same thing, right? Just algebraically rearranged. Okay? So here we go. Displacement is average velocity times time. So in this problem, we're going 3 meters per second. And think about that, you guys. 3 meters per second. Every second, we're going 3 meters. We're going to do that for 12 seconds, which means we're going to go 36 meters. There's our answer. Write it down, write down what it is, box it in, and we're happy. Okay? So that is that. And then I believe our last example is going to be finding time. So here we go. It says Roy jogs at, oh, that's worded terribly. This should say jogs 1,600 meters at 2.5 meters a second. So 1,600 meters at 2.5 meters per second. Again, it doesn't say anything about him speeding up or slowing down. Sorry, it doesn't say anything about him turning, that's what I'm trying to say. So I'm going to default to this equation. So those variables. So which of those variables is 1,600 meters? Well, meters is a displacement, right? It's how far. And 2.5 meters a second is a velocity. And we're looking, how long does it take him? How long? That's asking for time, right? So I got to solve this equation here for time. Now, in the previous slide, we learned that this was the same thing. I'm going to start with that because that's a little easier to solve for t, right? Because if we divide both sides, we're trying to get t by itself. So I got to somehow get rid of average velocity. So I'm going to divide both sides by that to get this. Cool. And now I just plug in my numbers. 1,600 meters divided by 2.5 meters per second equals, totally out of room. I wish I had a calculator handy. I do not. Frustrating. Here we go. 1600 divided by 2.5 gives us 640. And then the units, let's look at this. What happens over here is meters cancel out, and we're left with just seconds. Box in your answer, put a smiley face next to it, and we are done. Up next, acceleration.